So in our today's class, we are going to start the next concept. That is what rotational equilibrium. So this is the most important one for IIT, JEE and as well as NEET. So in this lecture, we are going to start, we will solve the questions related to torque. So that is what torque problems also. So let us explain what do you mean by rotational equilibrium first. Just it will take 5 to 6 minutes and then we'll solve numericals only. So imagine that rotational equilibrium. So equilibrium means is the word we are using familiarly from long back. So just imagine that. So I will go with another word called as static equilibrium. So static equilibrium is basically two types. So first one is translation equilibrium. So we have studied at the beginning of this chapter translatory motion. Do you all remember, everybody? All of you? Please respond.
Yes, sir.
That is what. So translatory equilibrium means, all of you remember that. So the net resultant force, that is what F net must be become zero. Means the force in X direction is zero, the force in Y direction is zero, and force in Z direction is also what? Everybody? Zero. So then we can say that kind of at this situation, so the F net will become zero, means the body is said to be in what equilibrium? Everybody? Yes, please. Translation equilibrium. Now, the second type of static equilibrium, so that is what we are saying, rotational equilibrium. That is only is our chapter, so our concept also. So rotational equilibrium. So if you have taken rotational equilibrium, here F net is zero. Can you tell me? F become rotational now, angular. So that here what will become zero? Torque net torque will become zero. Means in the sense of torque in X direction is zero, torque in Y direction is zero, torque in everybody Z direction is zero. So that is what we used to call as rotational equilibrium. So are you understanding, everybody? So this is what is our concept. So whenever the net torque becomes zero, then that is what is said to be that the body is in what equilibrium? Everybody? The body is in, yes, rotational equilibrium. Okay. So now if you notice it, let us go back to the translation equilibrium. All of you remember, we studied a concept called as COM. What do you mean by COM? Everybody? Center of mass. Okay. So if you notice at center of mass, the acceleration in translation equilibrium, the acceleration of center of equilibrium, center of mass is zero, because the velocity of center of mass is remains what? Everybody? The velocity of center of mass is remains what? Constant. Keep it in mind. If I take any kind of body, brothers, are you there? If I take any kind of body, so we are having a different particles. So now, different particles is having different velocities. This velocity is V1, this velocity is V2, V3, V4, or V5, or V5, whatever it is. But individual particles, the speed is maybe different. But if I take the overall mass, that is what the COM, the speed of a COM is remains what? Everybody? The speed of a COM is remains constant. All of you remember, the individual particle speed may be changes. In a particular body, the individual particle speed may be changes. But the center of mass speed is always remains constant. In which motion? Translatory motion. Understanding? Please write the statement. So what is the statement we are saying? Individual particles speed may change, but center of mass speed is always remains what? All of you? Center of mass speed is always remains constant. So that is translation motion. Now can you tell me in rotational motion, then similar way what will happen? Here A is remains zero. Then here what will happen? Angular acceleration remains zero because something is constant. Here velocity of center of mass is constant. Here what will happen? Our speed of a center of mass is constant. Here what will angular velocities remains constant. That is only called as rotational equilibrium. Understand, Rudreswar? Yes, please. So if you take it here, all of you remember, so static equilibrium is present. When we can say static equilibrium is present? If any kind of body, so I said already static equilibrium means two equilibriums. One is translation equilibrium, another one is what? Rotational equilibrium. If static equilibrium, when we can say static equilibrium is present, if you have taken all of you, so net torque about any kind of point, net torque about any point is zero, then we can say body is having what equilibrium? Everybody? Yes, please respond. That is what we can say static equilibrium. Because if a body is in rotational equilibrium means already it is in what equilibrium? If a body is in rotational equilibrium means body already it is in what equilibrium? Translation equilibrium. So whenever the net torque about any point, that net torque about any point of a particle is zero, then we can say a body is having what equilibrium? Static equilibrium. Understanding? So for example, if I take a pivoted point, okay, so there is a body which is attached to the pivoted point. So the force is applied somewhere. I don't know. Clear, everybody? So from a distance from the pivoted point, we used to take it as a what? Something. What is that called as? All of you? R. So if I take at this point or at this point or at this point or at this point or at this point, at anywhere, any point, the net torque become how much? Everybody, zero. Then means this body is said to be in what equilibrium? All of you? It is in static equilibrium. Clear, everybody? So that is what you have to remember. If a net force, net torque is zero, so any point, the applied force is particular point, but at any point of a body object is net torque is zero, then the body is said to be in static equilibrium. So that is what is the only concept of what is rotational equilibrium. Rotational equilibrium means what, everybody? Net torque become what? Net torque zero in all the directions, x direction, y direction, and as well as z direction. Now, based upon this, one big question and most important complicated question will solve. So that's all. It is enough to understand the things. Okay. So please mark it. Many questions are there. Now question number 1, we will solve it. Okay. So imagine there is a rigid surface. Draw neatly. Each part is very important in this. There is a rigid surface and two strings are coming down. So where a body has been attached to that. Okay. So imagine there is a rod which has been attached to that. So now, so it's like a balancing one. So now there is a small mass which has been kept in this. So to balance it, like you can see, so we all knows that this is the mass has been kept here. So, okay. So now the total length of the rod, all of you observe, the total length of the rod is 100 meters. What is the total length of the rod, everybody? 100 meters. And this rod is uniform rod. This rod is a what rod? Uniform rod. So whose mass is 10 kg? Whose mass is 10 kg? And the small mass which I kept here, the mass of this small one is 5 kg. How much, guys? Everybody? 5 kg. Okay. 5 kg. Now we all knows that center of mass, it is a uniform. Means center of mass is exactly located at the middle, 50 point. Am I right, Rudreswar? So this body is in equilibrium. Okay. So this body is in equilibrium. So now you tell me, all of you. So this small mass is kept 40 meters away from the end. See that, everybody. It's the 50 meters at the center of point. And this body has been kept how many meters away, everybody? Yes, please. 40 meters away from it. Now, we want to find the question. What is the tension? That is what? T1 and T2. So, what is the T1 and what is the T2? So, that is what is our question. So, let's start now. Everybody, please respond, guys. All of you?
Sir.
Yeah. So, now all of you check it. Option A, 80 newtons, and option B also 80 newtons. Sorry, A. And option B, 80 newtons and 70 newtons. and option C 60 newtons and 80 newtons, and option D is 70 newtons and 80 newtons. Keep it in mind. I will explain you. You all people observe very carefully. Understand the question is very important. Okay. So now first of all, two tensions is acting. Of course, you can check it. So this is the what axis, Rudreswa? If you take two axes, y-axis, x-axis, and there is another axis, we used to say z. So now this is what axis actually? Body, suppose imagine like it is equilibrium position now. So equilibrium position means by seeing this word, I can say that it is first. Step 1, all of you remember. So F net will become what? F net become what? If it is equilibrium means F net is what, guys? 0. Am I right or wrong? Yes. So 0. So if I imagine that this is the body, so that is the what? Uniform rod. And there is another body kept on it at how many meters away from the center?
40.
No, from the center. From the center of mass.
10
From the
meters.
center of mass. It is remaining how many meters? 10 meters. Correct?
10.
From end to end, it is 40 meters. Okay, clear? Everybody? Please
Yes,
respond. Yes. Now, if you have noticed it, so the weight of the body is acting downward direction. What is that? How much it is? mg. This weight of the body is also acting downward direction, which is mg. And one tension is acting. That is what T1. And another tension is also acting. What is that, everybody? That is what? T2. Okay. So now this is what? See that vertically it is acting. So which is 0? Fy is equals to what? Force in y direction become what? Everybody. Force in y direction is equals to what, guys? 0. Understand? 0. So means in the sense of what? Upward forces is equals to downward forces. So tension, two upward forces, which is equals to downward forces. Two downward forces. mg plus mg. Now tension T1 plus T2 is equals to, we all knows that M1. What is capital M? I have given you people. Capital M is equals to how much? 10 kg. Small m is equals to 5 kg. And G value is how much? 10 meter per second square. So substitute it. 10 into 10 plus 5 into 10. So which is equals to 100 plus
150.
so which is equals to how much, guys? 150. So we got one equation. So T1 plus T2 is equals to how much, Pradosh?
150.
150. So let me take it, that is. Now Roman number 2. So let me take now. So we all knows that F net is equals to 0. Then some other thing is also 0. What is that? Torque. Understanding? Torque also. Net torque is also 0. So net torque is also 0. So let us draw the rod. Okay, let me take the diagram. So it is from the perfect you can make. So first one till here, everybody understood, Amma? Girls, boys, everybody? Yes. So now let me take the total rod. What is the total length of the rod, everybody? 100 meters. Correct? So let me fill it with a light color so that it is very easy for us. Yeah. So this is what it is. Okay, this is totally how much under Pradosh? 100, correct? Now there is a block which is present how many meters away from the center? Sorry, from the end. Everybody? So
40 meters.
40 meters away from the things. And let me take, this is the center. Okay, exactly coming center. So let me mark it now. So center is present exactly here. So from the center, the body is present at what distance? Everybody? 10 meters. Correct? Yes, everybody. And from the end, it is present in how many meters? All of you? 40 meters. Okay. Now from this side, how much is remaining? Everybody? From the center of mass. This is what COM, center of mass. So from this side, how much is remaining? Yes, total is 100, correct. So this is how much? Everybody? 50 meters. Correct? Please respond, Amma. That is what. Now one tension is acting T1 upward direction, and this tension is acting also upward direction, T2. And at the center, something is acting downward direction. What is that? Everybody? Yes, please.
Weight.
Understanding? Weight of the body which is acting downward direction. Now, all of you observe very carefully. So here only you have to be very, very careful. So, if you have noticed it here, and this body weight is this body weight is 10. So that this mg become what? 10g. Am I right? Pradosh, will agree with me? Pradosh? Rudreswa?
Yes, sir.
And here this body is 5g. So this is also mg only. So this will become what? Everybody. This will become how much? 5z. Correct? This body is also acting downward direction. Okay, guys, please respond. All of you? Yes?
Yes, sir.
Yeah. Now, if you observe very carefully, all of you, now here the torque is acting. It is actually see that it is our left hand side. Now here is the torque as acting upward direction, torque not tension, so that the body will make clockwise rotation or anti-clockwise rotation. It is left side. Left side means always it will make what, everybody? It will make into the what? Clockwise rotation.
Clockwise
And
rotation.
here it is tension is in right side. So right side means it will make in what rotation? Everybody? Anti-clockwise. Because it is a balancing. Understand, Rudreswa? Clear? So it is acting left side, it is acting clockwise direction. This is clockwise, and right side it is making at everybody. It is making anti-clockwise. So that the both the sides it is balancing. Do you understand, everybody? Please respond, all of you. So we all knows that if it is a clockwise means torque is a what? Negative or positive? Negative. If it is anti-clockwise means torque is a what? Everybody.
Positive.
What? Positive. Okay. Now first, so we all knows that at the center of mass, you can check it, everybody. So we all knows that you can check it. Let us identify now. So be very, observe very carefully, and here is only understanding is very important. Now, T1 is from the center of mass. Let me take the at the center of mass torque is equals to 0. If you notice it equals to 0. Total net is equals to 0. So in this side clockwise is how much? T1 into 50, because we all knows that torque is equals to what is the formula? R into F perpendicular. Am I right or wrong? Everybody, please respond.
Yes,
that is what. So now this one will become what? Can I write it as a T1, tau1 into 50? This is plus this one will become what? Everybody, T2, not tau, T1. This is T1 into 50, and this is what? Everybody. This is also from the center of mass. How much it is? T2 into 50. T2 into 50. Understand? So that is what it will be happening. Now, if you notice it here, all of you observe. So first, if you check it here, this T1 is negative or positive? Because it is a clockwise. Clockwise means negative or positive? Negative. Negative. So that it will be modified into minus T1 into 50. Is it okay, brothers? Clear? Yes? Plus, next one, this one is T2 into 50, but still there is one more mass. One more mass is present. How many meters away from the center of mass? Verify it, everybody. How many meters away from the center of mass? Anyone? 10 meters. 10 meters. Now, can you tell me what is the direction of this one? Anybody? Suppose see that when I am having a slider, suppose this mass is present here. Now, automatically it will rotate clockwise or anti-clockwise? Everybody, please understanding and tell me. It will rotate clockwise or anti-clockwise? All of you?
Anti-clockwise, sir. Negative.
Clockwise it will rotate. Understand, Prados? This mass, this particular mass I am asking. So this is 5z. So it will take clockwise or anti-clockwise? Everybody. Of course, see, this T1 is taking clockwise and this T2 is taking anti-clockwise. It is balanced it. But from 40 meters, we are putting from the center 10 meters away, we are putting a mass of 5 kg. So which will take now what? Clockwise or anti-clockwise? Everybody, please respond. Yes, it will take the clockwise direction. So that is what it is balancing. Do you understand, brothers? These both are clockwise and it is anti-clockwise. That is how it is balancing both the sides. Do you understand? Yes, please respond, Amma, all of you. So that here what will happen? So this will become actually plus 5g into 10. That is what it is, weight. But this 5g become what? It is a clockwise. So clockwise means
Sir, negative.
Negative. So minus 5g into 10. Okay, guys, everybody? Do you understand, all of you? So that is what you have to understand. But it is why it is negative. All of you remember. This side tension, left side it is taking a clockwise, and right side it is taking an anti-clockwise. But if you notice it here, there is a mass which is 40 meters away from it. So this body is also, this both are taking clockwise direction, then only this opposite one anti-clockwise, so that this entire thing will be balanced. So that is the reason it is clockwise. Clear? Laksha, Aswita, understand? Yes?
Yes, sir.
So that is what? Equals to, which is equals to what? 0. So now you can tell me. So what will happen, everybody? So I can write this one as a minus 50 into T1 plus 50 into T2, which is equals to, I'll bring this 5G this side. So it will become 5 into 10, 50. So 50G. So all the direction 50, 50 will get cancelled. So I'll get a one more equation here. What is that? T2 minus T1, which is equals to G. So we all knows that G value is equals to how much, guys? 10. So can I say T2 minus T1 is equals to how much, Ra? Please respond. T2 minus T1 is equals to how much?
50.
T2 minus T1 equals to how much? 10. So we got two equations now. One is from torque, another one is from force. So T1 plus T2 equals to first equation. T1 plus T2 is equals to 150. T2 minus T1, which is equals to how much? Everybody, 10. Correct? Respond, everybody. So now add both the equations. What will happen? If you add both the equations, something will get cancelled. Everybody? 0, T1, T2, T1 get cancelled. So add both equations. If you'll add it, what will happen? 2T2 is equals to 160. So T2 is equals to 160 by 2. So what is the T2 equals to, everybody? T2 equals to how much? 80 newtons. Do you understand, Laksha? Clear? Next. Now you can take T1. Now you can notice it. T1 is equals to, so we can write T2 minus T1 is equals to 10 newtons. So T2 you take it. So T2 equals to how much, guys? Everybody? 80. So this 10 will come this side. Minus 10 is equals to T1. So T1 equals to how much, Ram? All of you, please respond. 70 newtons. Understanding? So what is the correct answer? So T1 is 70 newtons and T2 is 80 newtons. So check your answers and verify. So which is the correct answer? All of you? Option D. So 70 newtons and 80 newtons. Now you answer, those who not understand the question. All of you check it. Now T1 is how much force is exerting among? Tension, how much it is exerting? 70 newtons. Understanding? And this one is also, this one how much is exerting? Can you tell me now? This both are clockwise. So this one how much is exerting then? It will exerting 10 newtons. So 70 plus 10, 80. So this anti-clockwise how much is exerting?
80.
Anti-clockwise how much is exerting? 80 newtons. So that is why this will be lifted, balanced at the center of mass. Clear for those? Understand, Amma?
Yes, sir.
So that is what you have to remember. Anybody having any doubt, you can ask me. Clear, guys? Please respond. Everybody? Yes? Girls? Okay, ma? Yeah.
Yes,
So
sir.
basically you take your scale. Now this question, if you want to understand, generally you take your scale, put an sharpener or rubber, just you take some base and you put your scale. Now exactly if you put at the 30 centimeters, suppose 15 centimeter, it will be balanced. The 15 centimeter only what we used to call, guys? Center of mass. Correct? Now, if I put here one object and here one object, imagine like a tension. Okay. Now both the sides it is balanced because from the edge the distance is same, R and R. Am I right or wrong? Please respond. Everybody? Correct, Amma? All of you? Respond, Ra. So now always you see from the left side it will take clockwise rotation, like balancing also. Seesaw, you all people knows, correct? Seesaw. Seesaw means how it will be takes place. So the same principle it will be. So one person will sit. This person will always take clockwise and this person will take anti-clockwise. Correct, Amma? Everybody? So always you remember,
Yes,
this one will take clockwise and this is anti-clockwise. This is clockwise and this one will take anti-clockwise. So what will happen now? I am putting here one more extra person. Now you tell me this person will take clockwise or anti-clockwise? Anybody? See, actually this person is taking anti-clockwise and this person is taking clockwise. Now I put some object towards to the right side, not exactly at the center of mass, closer to the right side. Now you tell me, it will take clockwise or anti-clockwise? The scale will fall in this direction, this direction. Clockwise direction. Do you understand? Rudresh, correct? Yes?
Yes, sir.
That is what you have to remember. For example, if I put this center of mass, this extra mass in this direction, it will fall in what direction? Clockwise or anti-clockwise? Anti-clockwise. Understand? Scale will fall into anti-clockwise only. Understand, Amma? Everybody? Yes, that is what. Now the same question we can solve in another way. So let us see how we can, how you can find these things. So let us imagine again. So there is a rod. So we all people knows that. Okay. So exactly at the center, it is acting something. What is that? Weight of the body. That is what? 10g. And there is another body which is present. What is that weight? Everybody. 5c. Clear? And this is the tension T1. And this is the tension what? At this point. Tension what, everybody? T2. Okay, wow. Now, all of you observe. You can take it. Let me take this is a point A and this is a what? Point B. Now we all knows that net torque is equals to what, everybody? Net torque is equals to, please respond. Net torque is equals to 0. Okay. Now let me take, we want to find this one. Let me take the torque at A point. I will consider as a 0. So now can you tell me torque at A point is 0 means? Now we all people knows that. So if you consider this alone, so this is R actually. How many meters actually it is? 50 meters. From here to here, it is 10 meters. But from here to at the end, it is also how many meters, everybody? It is also how many meters, guys? Please respond. 50 meters. Correct, Amma? All of you? Respond, guys. Yes? Now,
Yes, sir.
I will consider torque at A point is 0. Now, can you tell me both two points, this side it is a clockwise and this body is also in clockwise. Now from this end to the body, what is the total distance? Anybody can tell me? Directly I am going to this point. What is the total distance, Rudreswa?
60
do you understand it? And from the A point, I am taking torque at A point is 0. Understand, brothers? Directly at the A point I am taking 0. So from A point only I will take it everything. So from A point, the COM, center of mass, is at how much distance? Everybody, please respond. 50. From the A point, the extra mass is how much distance? Everybody, 60. From the A point, T tension 2 is in how much meters? How much meters? From A point,
100.
100. Understanding? So that is what you have to remember. Now you write it. So these both are clockwise. So can I write it as a minus 10g into 50? Is it okay, everybody? From the gravity, minus 50 into 10g. Next, this is also minus 5g into how much distance from the center? From the center, sorry, from the A point. How much it is? 60. Plus, it is anti-clockwise. Plus T2, how many meters from the A point? From the A point, how many meters it is? Everybody. How many meters, Ra? 100, which is equals to 0. So that's all it is. Now you can solve this equation. So T2 into 100, which is equals to, I will say, 10g into 50 plus 5g into 60. 5g into 60. Now, I can get cancel all the directions, something will get cancelled. 0, 0 can cancel everywhere. Can I cancel it or not? All of you? So what else remaining? So 10 T2 is equals to here. How much it is remaining? Everybody? 10 into G value is also 10 into 5 plus 5 into G value is 10 into 6. So how much is the answer? 10 T2 is equals to, I can get cancelled 10 also. 10, 10, 10 can get cancelled. Now directly you tell me how much is remaining. T2 is equals to, speak loudly, 10 5s are how much, Ra?
50 plus 38.
50 plus
So
30.
10 5s are 50 plus 5 6 are how much? 30. Okay. So directly I got it. So how much is the T2? Everybody?
18.
18 plus it is in equilibrium. So do you all understand it? All of you? Everybody? Clear? Please respond. So whenever you are finding, this is how you need to do it, either this way or this way, your choice. What way you want, you can solve it. So this is how you have to solve the question, equilibrium question. So please make sure you are able to understand this question. I hope you all understand. Anybody having any doubt, you can ask me. Or else let us start the next question. Shall we start next question? Everybody clear this question? Anything doubt? Please let me. All of you? Yes? Pradosh? Understood, Ra?
Yes, sir.
Next question. Next question, let me consider there is a wall who is having a rough surface. So rough surface means immediately your mind should say something. We studied rough surface means something is exerting.
Friction. Friction is
That is what. So it's a rough wall. So rough wall and there is an object. Let me take a different color and draw. So there is an object which is actually kept to the wall and the force is exerting. Force is exerting F. Okay, everybody. So this is what, and this object is in state of rest. So now imagine like it is a cube. So each side is 2 meters, and here also the size is how much? Everybody? Yes, please. How many meters? 2 meters. Okay. Now the mass of this body is 2 kg, and the G value is 10 meter per second square. Question is, what is the torque about? Be very careful. Question you should understand very carefully. What is the torque about? Torque about center of mass. So which is the center of mass? This is the center of mass. Do you understand? Please respond. Center of mass means exactly I am putting at the center because it's a dimensional object. Center of mass produced by N. What do you mean by N, guys? Yes, please. And all of you, N reaction by wall. N reaction by wall they are asking. So be very careful. Produced by N. What do you mean by N? Everybody.
normal.
Normal reaction by wall. Okay. Option A, 20 Newton meter. Option B, 40 Newton meter. Option C, 0 Newton meter. Option D, 10 Newton meter. Okay. Now, this is one of the most important and interesting question. Be very careful. Just imagine this object is like I rotated clockwise 90 degrees, anti-clockwise, and imagine that this object looks like this. Is it okay, Pradosh? Now we all knows that this is the center of mass. This is the center of mass. So imagine that now the what they are asking everybody, as this object is in rest in the sense of it is in a what actually? It is in a what actually? Equilibrium. Now, observe if it is in equilibrium means, check it everyone. So, what is the torque about COM? About COM, actually the force is exerting like this. Now they are asking torque about the COM when produced by N reaction. So, the force is exerting downward direction means opposite to that something is exerting along the same path. What will be? Reaction. Force is downwards means reaction is in what direction? All of you. Upward direction. That is what. So if any kind of force is exerting towards the center of mass, we studied torque is equals to how much? Passing through the center of mass, torque is equals to how much? Day before yesterday
0, sir.
0. So the force is exerting like this means the center of mass, the normal reaction which is exerting along the center of mass will be in this direction. So that what is the torque? Torque is equals to how much? Yes, please.
0.
So if you have choose the answer 0, so you have been done blunder mistake. So the answer is not 0 because they are asking normal reaction done by the force not. What they are asking? The
Done by the wall.
torque produced by COM. Torque about COM produced by N reaction about by what? Everybody. About by wall they are asking. So wall we all knows that as the body always suppose imagine the body is sliding downward direction. So frictional force always act in what direction? Everybody. Yes, please. Force of upward direction. So how much it is? We have to find that one. So imagine this is the wall. Now object is here. So something is acting downward direction. What is that, everybody? Yes, please respond. mg. So mg is equals to 2g. Right? Pradosh? Now, so if the weight of the body is acting downward direction, force of friction is acting what direction? Everybody? Upward direction. So I can say if I draw the free body diagram, F is upward and weight of the body is downwards. That is what 2g. So now what will happen? F is equals to 2g. G value is 10. So that 2 into 10 which is equals to how much, guys? Force of friction. Force of friction is how much? Yes, please.
20.
Friction is equals to how much? All of you. Force of friction is equals to 20. In which direction? I consider Fy is equals to Fy is equals to 0 because it's the y-axis. So Fy is equals to 0. I got it force of friction. Force of friction, which is equals to how much I got? All of you. 20 Newton.
20.
Understand? So if this is the wall and this is the object, so force of friction is how much, Ra? Speak loudly, 20 newtons, and weight of the
20.
body is acting in one direction. Now, so now there is a force which is exerting on the center of mass. So that is what F force. Okay. Now we can notice it. So in any kind of normal reaction which is acting along the center of mass, just now I said, which will become what? Which will become what? 0. Correct or not? 0. Now let us consider in x-axis, the normal reaction is acting above the center of mass. Imagine this is what is my normal reaction. So means in the sense of Fx equals to 0. So imagine my body is, the force is acting like this and normal reaction is acting like this. So can you tell me N is equals to what from this? N is equals to what? Because if it is acting along the center of mass, then F equals to what? N equals to what? 0. Right or wrong? Everybody? Torque equals to 0. Are you understanding, Amma? Please respond. So imagine that now it is acting. I'm above the center of mass. Now you tell me this body will take clockwise or anti-clockwise? Just before like a rod case. Now I am taking a normal reaction is acting here. So now it will take clockwise or anti-clockwise? Yes, please.
Clockwise.
Clockwise. Understanding? So this normal reaction, it will take it as a what direction? Clockwise direction. So in Fx equals to 0, if I have been taken, so normal reaction is equals to force. Normal reaction is equals to force. Now, be very careful. We all knows that N is equals to F, we got it. Now there is a equation, we have to form it now. So we all knows that if it is equilibrium, net torque is equals to what, everybody?
0.
0. Okay. Now net torque is equals to 0 means torque at center of mass. Torque at center of mass is equals to how much?
0.
Torque at center of mass equals to how much, guys? 0. Okay. Now observe the very carefully the entire picture. So this is a wall who is having a frictional force of how much is the frictional force? Everybody? How much is the frictional force? 20 newtons. And this is the object. What is the length of the object I have given? This side, anybody? Yes, please. 2 meters.
2.
Means in the sense of center is exactly present middle. Now weight of the object is acting downward direction. Weight of the body is acting downward direction 2z and force is acting along the center F. Now center of mass is located how many meters away from the wall? That is what is the question. Center of mass is located how many meters away from the wall?
1 meter.
Yes, please respond. How much it is? Everybody?
1
1 meter. Understanding? Now you tell me,